Hello everyone. Welcome to Karmada community meeting. Today is October 5th, 2024. And let's see the agenda. Hi, Joe. The first one, Joe. Hello, Joe.
Hey, Honkai. Do you mind if I share my screen?
Okay, sure.
Okay, let me share. Can everyone see my screen? Can everyone see my screen?
Yep.
Yes.
Okay, so let me go to this
Yes.
one. Okay, so let me go to this one. Thanks for all your comments, Honkai. So I think we made a lot of progress. So yeah, for this one, this comment, I can just make the change, right? So the other maintainer has been making a lot of great progress for standardizing how we do all of these things across the code base, which I think is meaningful. So I can just abide by it and then make these changes. So this one, we'll make the changes.
Okay.
Oh, okay. So right now, if there's a validation error, what the current implementation is doing is just setting the ready condition to false with a message and then emitting an event. So for this, yeah, I do agree. As we move forward, right, maybe we'll have to do a lot more validation. So it's probably not the best idea to have one specific reason for each one. So in that case, do you think we should just have one generic reason, maybe something like invalid Karmada instance or something, and then the error message would describe exactly what the validation error is? What do you think?
Yeah, that's the idea.
Okay, so we'll create just one generic validation reason and use the message to describe the error. Okay. Oh, this one. So the reason why the name of the Karmada instance is used as a prefix for the secret name, there's two main reasons for it. One of the main reasons is that I'm trying to stay consistent with what's already been done in the code base. So let's see if I go here. Let's see. Oh, here. And so this is already the convention that's used. So each Karmada instance will have a set of resources linked to it. And today there's this convention where all of these resources, so for instance, the deployment for API server or certs, secret certs, or like controller manager, each one of these resources the name for them will be generated using this convention where the name of the Karmada instance is used as the prefix. So for API server, if the name of the instance is like K1, it'll be K1 Karmada API server. That's the first reason, is just being consistent with the current convention. And then the other reason is that we can have more than one Karmada instance in a namespace. So using the prefix helps to differentiate between those instances. And for our use case at Bloomberg, where we building a managed Karmada platform, the way we
Mm.
envision things working is that for each tenant who wants to onboard to our platform, there will be some namespace linked to that tenancy, and that namespace they can create their Karmada instances. So those are the two reasons why.
Okay. First, I didn't notice that we use the Karmada instance as the uh, secret prefix. I think we should consider to um, maybe we will update it as uh, maybe we'll update this the name this time. And sure, I think I can keep another look this. And for the second thing, I think uh, I can understand that the case that multiple Kamada instance run in same namespace. Are you using this way?
Yeah, that's the plan. And also, given that there's nothing that would prevent that from happening, I think we will have to use that prefix. Otherwise, it opens up the door to errors, right? There's nothing that prevents someone from creating more than one Karmada instance in one namespace. So the names will have to be differentiated.
Uh, so why don't you put each Kamada instance to a specific namespace? That's I think more easy more easier to maintain the instance, right?
Yeah, um, we can do things that way. But even if things are done that way, though, there's nothing that would prevent someone from creating more than one Karmada instance in a namespace.
I'm not sure if it works. If there's if there are any risk to do that. I mean, put multiple instances in a namespace. Um, the Kamada components might be uh, might be store some metadata info. I, I'm not sure yet.
Okay. But for now, do you think it's sensible that we use the prefix? Because I think today that was done for the secrets as well. So if I go here, so by doing that, we will stay consistent with how things are done. So for instance, I don't know, like Karmada cert name, right? It uses the
Mm.
same convention. So if I go, let's see, like let's for instance, like admin cube config, right? They all use the same convention, all use the same naming convention, not just the cert, but all the Karmada components.
Hmm.
Yeah, so this using this will will maintain consistency with how all the other resource names are generated.
Hmm. Uh, see Charles. Are you? Yeah, Charles is in the meeting. I'm not sure. Charles, are you going to um, make changes to this to the name convention?
I prefer to fix the uh, I mean the secret name doesn't contain the 那个release name 就是 yeah
Yeah.
Okay.
I thought the secret name is a fixed name.
Yeah, I think the key point is if we need to support the case that run multiple Karmada instances in a same namespace. If we want to support that case, then I think we should have the Karmada namespace, Karmada instance name as a secret prefix. But if we don't want to support that case, then we probably don't need the instance name.
Yeah, I agree with you. Also, another thing I think is worth considering is backwards compatibility. So today, if we change this convention, let's say I'm using Karmada Operator today to manage life cycle of some instances. If a future change changes this convention, then that will not be backwards compatible. It will just break because as soon as the operator tries to reconcile previous tries to reconcile instances that already have, then as part of reconciling, it will look for resources with the old names. And given that it won't find them, it will try to recreate them, and that will just break existing use cases.
Yeah, I'm not sure. Just a guess. I think the controller will regenerate the secrets as the new name convention, right?
Yeah, and so for things like the search, that can be a problem because it will generate new search.
New
So
search.
yeah, for deployments, it's not an issue, but for search, it will be.
Okay, I think maybe Charles can have a local testing for this case because he tries to change the name conversion.
Okay. Do you think we can support the use case for having multiple instances in one namespace?
I think we need another test for this. I'm very concerned about this use case.
Okay. I see. So one of the rationales for this is that, like for instance, for managed Karmada, one way we envision it working is that for a tenant who wants to onboard, um, we will allocate a namespace for that tenant. And also other things like resource quotas to limit just how many control planes can be provisioned. But that idea falls apart if we will be creating one separate namespace per instance. Okay, so maybe we just need to think about this a bit further, so I can just put a note here.
Okay.
Further, and okay, and then let's see if there's anything else. Okay, this is along the same line. Okay, I think that's it. Do you have any other comments?
No, I do you think we can split this PR, and for example, we can have a PR to focus on the API and the validation part, and the other PR can focus on the implementation.
Okay, yeah. So
Okay.
let me think. Okay, we can do it that way, yeah.
Okay, thank you.
Okay, that should be it for this one. So this one.
Sorry. I want to share a reason for why I don't prefer the secret name has that prefix. Our Karmada has several install. Uh, that if Karmada is installed by operator, there are several optional components, just like Karmada search, Karmada is scheduled meter, or Karmada web, Karmada
This scheduler.
several optional components. The user may install these optional components by other methods, just like Karmada ctl s-on command. If your secret doesn't have a fixed name, the user may
Oh, trust is lost. Dropped.
sorry,
Hey.
I lost.
Okay, you're back.
Can you hear me?
Yeah,
Can you hear me? Simply put, if you install Karmada by Karmada operator, and if that secret doesn't have a fixed name, then if the user wanted to install Karmada search by Karmada ctl in s-on command, they may have installation problem. They may install it failed. So if we fix the secret name, that means doesn't have that prefix. It will be more convenient for this problem.
Yeah.
Okay, I do have one question. Let's say we go down the path of not allowing more than one Karmada instance per namespace. How would that be enforced?
As far as I'm concerned, I think now we may have some problem to install multi-command instance in just one namespace. Many installation methods install the Karmada API server by host network, and it occupies the same port. If you install Karmada API server multi instance, I think the Karmada API server may have some problem. Maybe operation, or maybe Karmada installed by operator is not a host network by default, but actually other methods use host network by default. So I think we may now have some problem to install multi-instance in just one namespace. I didn't I didn't try, but we can test it.
Yeah, I think so. So, can you help to run a test for this case?
Oh, okay.
Okay. We'll see.
Okay. Yeah, so and if that works, then I think we can explore further if we can have this support without any issue. My instinct tells me that there won't be any issue because Karmada control plane is like vanilla Kubernetes control plane with some extra components, right? And usually with like managed Kubernetes services, it's possible to have multiple control planes per component. But yeah, I'm looking forward to see what you find, so that we can further this discussion. Okay,
Okay.
thank you, and thanks for all your hard work on the standardization effort. So the next one is this one. So this one we started reviewing, and from the last conversation we had, we were discussing what type of services we should support. So as far as I can tell today, for the Karmada API server, the supported service types are either cluster IP, node port, or load balancer. There's no support for external name, which does make sense because external name would just be a CNAME and core DNS. And I don't think that would make sense for the API server. So I addressed your comments and came with this structure, which I think should cover all use cases, right? All those three service types.
So the pod here means the cluster pod and node pod. I see. I think it looks good.
Okay. Then in that case, I wanted to get your feedback before making this change. So if there are no further comments, then I'll just make this change and then this should be ready to go.
Okay.
Okay, thanks. And one more thing. So this PR has already been merged. This was the enhancement we added to the scheduler estimator and components for how they discover scheduler estimator services. I was excited when this got merged because I want to use it, but then I tried using it with the latest release and it was not part of it. I see that this is targeted for V1.12 milestone, which I think is coming
Yes.
out, yeah, end of November. But I was just wondering if it's possible to release this sooner, because we do have a use case for it, and I'd like to bring this in to actually use it.
I wonder if we cut a beta or alpha release, that's worked for you.
Let me see. So V1.12 alpha release.
Yeah, probably beta.
Okay. Yeah, that works.
Okay.
Yeah. And any idea on when you can do that?
When do you want it? This week works.
Okay. Yeah, that works.
Do you prefer alpha or beta?
We can do alpha.
Okay.
Yeah, that's fine. Okay, thank you. And I just one more thing. I have one question. This is something I've been curious about, and haven't had time to explore it, but given that you're the expert, I think it's the perfect question for you. So let's say I have a member cluster, and then it's joined to more than one Karmada control plane. What would happen?
Sorry.
Let's say I have one member cluster,
Mm-hmm.
and then joined it to more than one Karmada control plane. What would happen in that scenario?
First, during the sorry.
Jonathan, from our use case, so the Karmada, so the scheduler talk to the Karmada by the estimator service, right? So I just curious why when it will happen, like for one estimator, one cluster estimator registered for multiple Karmada control plane. So do you mean like the Karmada control plane running on multiple clusters, or on that cluster you have multiple Karmada control plane?
This is a question just out of curiosity. So once I have a Karmada control plane, I can join a member cluster to it. I'm just curious to know what would happen if the same member cluster is joined to multiple control planes.
Oh, so I can explain a little bit of the flow, the scheduling flow. So first, if we enable the Karmada estimator during the scheduler, the scheduler will send the gRPC request to the estimator, like to estimate if this cluster has enough resource to run some number of replica. This is what it's doing. So if you have the estimator registered to multiple Karmada controller or multiple Karmada control plane, it means like when you do the scheduling, it will get multiple, like you will get a request from multiple control plane if they enable the estimator, yeah. So the estimator it's just a gRPC server.
Okay, I see.
I don't think it will cause any management issue, but it just means like when they do the scheduling, if the scheduler connect to the estimator, it will send the gRPC request to the estimator.
Okay. Thank you. This is all I have, so I'll stop sharing. Thank you, Honkai and Vice Pen. Thank you.
Okay, thank you. The next, Mihash.
Hey, Honkai. Yeah, I wanted to sync up with the PR, which I know this has been open for a while now.
Yeah.
I wanted to sync up on this. I think our previous two meetings got moved. But yeah, I took a look at the branch that was created. I was a little bit surprised that the entire new branch was there. But obviously, thank you for all the work put into that. That's really helpful. I think when we were implementing our branch or PR that we opened, we were primarily thinking about this in terms of one, the actual resource was just going to get sent to a single cluster, meaning that replicas wouldn't be separated in any way. And then we were also using the failover history as a way to determine scheduling after the failover, meaning that the actual resource would never get rescheduled to the same cluster that it just failed over from. I think with the branch that you shared, I think you and Chang made it a little bit more generic. So you were also including the cluster failover. And I think you ended up using the actual like eviction task to take care of generating the failover history. So I was just curious, currently we've been using our changes in dev, and so that's been working pretty successfully. I was curious how you wanted to move forward with this, since there is a decent amount of overlap between what we've done and then also the branch that you were able to share. I don't know if it would be helpful to maybe split up the PR in that case, and then we could just handle the existing use case that we provided, and then you can add on top of that, or essentially what would you prefer?
I actually I tried to think thought about the API part, and I asked the Changjin to make a demo for this. And I know you are running your your implementation in a dev environment. So I'm thinking it would be great if we can make if we make a agreement on the API part, so we can you so that you don't need to maintain a private commit in your side. So I actually I wonder if you how do you think the API, and is there is it possible um, to move to this API, and
Yeah, I think generally it looks good. The one concern I had is you have a list of clusters before failover. So like the original clusters. What we've done as part of our implementation is we want to make sure that that resources are never rescheduled to the same cluster that they failed over from. And this is kind of something that exists in Karmada today, where if you're using a instantly eviction mode, or like using a graceful eviction mode with a very small grace period, then it's possible that during the scheduling step, Karmada won't be able to filter out the clusters. Because right now, the way Karmada schedules is it takes a look at any possible eviction tasks that are on the resource binding, and then it filters out those clusters when determining suitable candidates for scheduling. So we don't want to run into a case where we have an application that's been failed over, and then our grace period is set too low, and the actual cluster that is included in the eviction binding isn't used to filter that out, and the application gets rescheduled to the same cluster. So what we were doing is using the failover history as a way to filter out clusters that we originated from, and making sure that essentially they're not rescheduled to the problematic cluster. So when we're talking about like a list of clusters, I was curious because is that going to be a historical list of clusters on which the application was previously running on, or is that going to be just the immediate cluster that the application failed over from? Because if we end up having just a full history of clusters before failover, then we can't just start to filter out all of those clusters, because you might not end up having any candidates left, right? We could have just or we could just use the from cluster part of the failover history item and use that as a way to filter out the cluster. But yeah, I was curious what the use cases were for having the entire like historical list of clusters. And I mean, we can also continue this conversation on the actual PR up to you. But yeah, I was curious what our next steps should be in that case, because I think some of the pushback was just like the API design on our side. And so if you want us to align with the API that it seems like there is a decent amount of overlap between our APIs. It's just that yours is a bit more comprehensive. we could add those fields to the API definition if necessary.
Yeah, I think I'm trying to make a alignment at least at the API part. So I can explain the API a little bit. From I think we two user stories we want to handle. First one is we want to pre-reserve some metadata and feed the metadata to the new cluster during the failover. And at this point, we in this API design. Let me see. At this point, we don't need the failover history here, and the reason is we can have a sorry. Okay. Yes, here. Now here, in the graceful eviction task, we introduce the preserve the state here. So in the task we have a from cluster, and
Yep.
I see. Sorry, I don't remember clearly why we don't need the history at this point. But the second use case, as you mentioned, we need to make sure the scheduler won't select the previous cluster, so that we can do that by the failover history.
Yeah, so currently what we're doing is within the failover history, we have the from cluster attribute as well. And then we just filter that out during the scheduling step.
Yes, I think that makes sense. And we should do that. So I think why I want to keep the API alignment because I'm concerned about if you have a different API and or different implementation, I think it will get some trouble when you upgrading Karmada next time.
Oh, I mean, yeah, totally agreed. I think that's why I wanted to get on the same page. So yeah, with the API, we don't have major problems with it. I was just curious what the next steps are with the PR that we currently have open, since it seems like there is a decent amount of overlap between what we implemented and what you and Cheng implemented.
Okay. I think we can keep discussion on the PR, and if you have any further questions or comments about the API, if you agree, if we can make an agreement with that, we can. So I think the we can continue to move forward. Let's consider how to twist the implementation.
Okay, sounds good.
Mhm. So yeah, the API design in my personal branch. So you can just tick it to your PR. That's totally okay.
Okay. Yeah, we can match the API as suggested.
Mm-hmm. Okay,
Okay.
sound good. Thank you. So if you have any comments about the API, please leave a comment on the PR. Okay.
Yeah, will do. Thank you so much.
Okay. Okay. The last one, Leon. Hello,
Hi,
Leon.
Hongtai. How are you doing?
Yeah.
Let me share the discussion thread. 1 second. Yeah, so today we mostly want to align on how to handle the federated priority class and how to propagate them into like the member cluster. Like previously you mentioned, for the Karmada schedule estimator, it's actually dynamically getting these priority class from the member clusters. So this is how so the priority class are actually propagated to the member clusters. So on one side, do we use the federal priority class on the Karmada control plane? If not, is there an alternative to that? And on the
I
other
think
side,
We lost Hongtai.
sorry, I just sorry, Leon.
Mhm.
Hello. Can you hear me?
yeah, I'm still here. I can hear you.
So I mean, if we can have a brief introduction of this feature, so because Kevin is here, he might be interested in this.
For sure. So to start from the beginning, the context is that currently, actually, Sean, do you want to talk about your contribution to switch from rate limiting queue to priority based queue? And then we can start from there.
I think we can just go through the high-level ideas and also our requirements. Yeah, I can. So yeah, I can share my screen. I think I'll just go through all the doc. Okay. So let me share my screen.
Every time we add a node. Yeah.
Okay. So for this, we basically needs priority and preemption features. Oh, can you guys hear me?
Yes.
Yeah. Okay.
Yes.
How we want to, well, and we also have see that there is another proposal for the same features, and basically I will just tell describe the difference. So for our feature, we designed to use a resource estimator as a service to find the victims. And after all the scheduling loop has finished, and we will use the feasible clusters, which is retrieved from the previous steps, the filter cluster steps, and then talk to the resource estimator. Since the resource estimator has all the accurate information of the cluster, and we currently use that to help us to get all the information and filter out the victim nodes, and then do the sorting and return all the victim bindings to the scheduler, and we will filter out the list number of bindings, and then use that as the preemptees. And in the scheduler, we'll remove all those preemptees in our current design. And I think this is the high-level overview of it. And we have several things that need to align with, like first is the API, and also the I think maybe you can start with the behavior, because we also see that there's a lot of discussion. Depends on, like, if there is a high priority bindings, don't have enough resource, and will we block all other resource binding instead of keep scheduling other low priority bindings? What do you think about that? Or do you need me to introduce more about our proposal? Or
Yeah,
oh, okay.
yeah. Actually, we have two proposals for the same feature. But for now, we haven't made any decisions. So I see. I just posted a comment on this talk just before the meeting about the if we will have a federated resource quota. I'm actually I'm not sure we will have it because uh because the I need the reason why we need a federated resource why we need a federated resource
I mean, federated priority class.
priority class. Yeah, sorry.
Got it.
The federated priority class. Why we need that? Because I think the priority class we can get the priority class from the application, and then we can get the concrete priority from the Kubernetes private class. So I'm not sure what's the benefits if we have a federated private class.
I think
this is
sorry.
what we propose, or like what we propose. We didn't introduce another like priority class in the command layer. We just reuse the definition from Kubernetes, like the priority class and the priority class number is all like from the application, either from the deployment or from the job.
Yeah, I think for us, we don't use that yet. We don't, and so also we don't have preference. And the reason we put that here is just we think if we directly use a priority class as the current Kubernetes, we might need to support like the same functionalities as Kubernetes, like all the same policies, and also if in the future we will like to extend other behavior for this feature, and we'll probably need to introduce other field or other policy other than the current priority class, native priority class. But we currently don't use that, so it's just a proposal. Yeah.
Yes, I think we can have the federated private class when there is a real world use case. I think we can do that at any time we need it. But for now, I don't think we need it.
Yeah, sure.
I have a question about your use case. How do you manage the priority class between Karmada control plane and the memory cluster? Are you going to propagate the priority class to memory cluster by Karmada?
No. So we have our own like you can think tenants metadata management system. So we populate the priority class, also the resource quota to the member clusters. So that is why we don't want Karmada to manage the priority class for each tenant. And our priority class is always binding with a type of resource quota. And then in our job, we expose the priority class name or also the number like in our job. And then we have own control like flow. We're going to design like we allow some user to be able to pick up high priority job. Like we have the policy control in the beginning, and then the user can specify high priority job only for a small group of people. So basically, yeah, we only wanna the Karmada is more like behavior, like the scheduler able to find the victim for us and kill the lower priority job to kill the victim job. Yeah, the priority priority class management is handled by us. Yeah, this is our use case. Yeah.
I see the similar way as you manage resource quota, I guess,
Yeah,
right?
so that is why we didn't turn on the federated resource quota.
Okay. So another question is I think that's the difference between the two proposals is if we want resource binding to hold the priority or priority class name, I would prefer to let resource binding have the priority. So so that the scheduler don't need to get the priority from priority class.
Yeah, this is our proposal is like in our interpreter, like we can translate the priority class like from our compute job to the resource binding. So this is like we introduce the priority class name in the resource binding, right?
Sorry, do you mean you prefer the priority class name in resource binding, right?
Yeah, we prefer that way.
Why? Sorry.
Oh, because this one, because the resource binding is like in the scheduling queue, right? So so we need a priority. So and then we have to have those priority class number in the RB, right? Otherwise, how the priority queue works, the high priority the high priority resource binding should be put before, like ordered before the low priority resource binding, right? If we are going to use a priority queue.
Oh, I think Oh, sorry.
I'm not familiar with private the queue. Do you mean the queue relied on private class name to sort the?
No, we also need a priority class number. We need both, right? You need a just like what we have in the pod. You have the priority class name and also the value. And then so if we want to introduce this priority things, it's more like the high priority resource binding should be scheduled before the low priority schedule, low priority resource binding, right? When they push that into priority queue. So that's the one reason we put the priority class and the value in the resource binding.
I'm sorry.
That will also
I mean, right now I think he's asking like, do we need to put priority class name here, or can we put priority?
Yeah. We can have both, right? You have a priority class name and also the value. The value is used like for order for the comparison, right?
Yeah.
Also, if user wants to make a certain priority class non-preemptible, then we need to dynamically get that information on the member cluster with the priority class name.
Yeah, the flow is the scheduling flow is like if I have a high priority resource binding and in the scheduling cycle, if it couldn't find any cluster, and then in the post scheduling cycle, we are going to send a request to each cluster's estimator. So each cluster estimator will find the low priority job to us, and then we can have some algorithm to find a victim job and then delete those jobs from the control plane. And then those high priority jobs will be re-queue again. And since they have the high priority, they are kindly be able to put in the beginning of the queue and then trigger the whole rescheduling. It's just similar like the current pod preemption. We just like you can just think resource binding is just like a pod. And then the queue is similar like the Kubernetes scheduler queue is a priority queue.
I'm still trying to understand why we need to have them both.
Yeah. So here the question. So at least from our side, we don't need to introduce a customer resource like for priority class. We just like reuse the definition from Kubernetes and put that in the resource binding. That will fit our use case. And then I don't know, like for another PR, if the owner is here, maybe he can explain why he want to introduce this priority class. Yeah, we just explain our usage and yeah.
I think we just need to turn on that flag, like turn on that share method flag.
Yeah, I'm trying to understand. So you mean we add a field called a priority class name to the binding object, right?
I think we also add the priority the number, not only the name.
Also the value, right?
The value,
right?
The value, yeah.
But how about the other fields, like if we want to kind of change the like preemption policy, do we want to provide that functionality?
Yes, that's present at another proposal actually.
Yeah, this is yeah.
Yeah, so I'm just thinking about how many fields are we going to introduce, and the difference between keeping them in another object, or directly have them over in the binding resource mining object.
So you said you want to avoid adding new fields to the binding object,
Actually,
if
no
possible.
opinion yet. Just trying to understand what are the difference and the motivation, or what's your consideration between these two options. Yeah.
Oh, I see. So their preemption policy is inside the priority class. Let me
Yeah,
see.
I get. I think I get you now. So you need the priority class because you need to get the permission policy from it, right?
So we just yeah, so we just reuse so we just make so from our perspective, we think resource binding is very similar to a pod. So if we want to introduce the preemption policy, that should be similar like in the pod. So currently the preemption policy is in the pod, right? The pod has a preemption policy, has the priority class name and also the value. So that is why I want to, if we want to have preemption policy, it should be in the resource binding, and this information should be interpreted from the customer resource, if even from the deployment or a job, right? Because the oh no, so I see. So the preemption policy binding to a priority clause. Okay, I see your point now. Then, so if you want this priority class has preemption policy like number. So which means that we need to surface the priority class to the Karmada control plane. Yeah, sorry, I make a mistake. The preemption policy should be binded to a priority class from Kubernetes. Not to the pod.
Right. That's what I'm curious on. So the
Yeah,
in Kubernetes, it's not in the pod, but in the
priority
priority
class.
class.
Yeah.
Yeah.
On like a non, probably just on a non,
Yeah, so just to share my understanding, so maybe it's like we are actually caching the values. I mean, if you want to have the fields in the resource binding, it's like caching from the object. So when scheduling, checking all the things, you don't need to kind of get the priority class again.
Can you check your, yeah.
That's what
Yeah,
I
yeah,
see.
I see. So, so which you mean, so your suggestion is more like in the Karmada control layer, in the Karmada control plane, like the Karmada API, we create the priority class, right? We reuse the priority class of Kubernetes, which has the value and name and the preemption policy. And then in the controller, not controller, in the scheduler, we can cache all the priority class. And then
Yeah, it's like the
I
internal
see.
data structure.
And yeah, and then in the resource finding, we can only have the priority name to build up the linkage between the priority class, class number and the name, and then do the ordering. Is that possible to do that? We still need a number, right?
Actually,
uh,
I prefer to let result binding have the priority value and the preemption policy, so that the scheduler don't need uh, get the priority class and to get the priority value. So I think I am hesitant to let scheduler to do much work that we can do that before the scheduler process.
Yeah, it's like some other flow just copy, copy the values from the object priority class to the fields in the resource binding, right? So,
Yeah, yeah,
when scheduling calculates all the things, it doesn't need to check, check the other object. It just check the resource binding. Yeah.
yes.
Yeah, that's a possible option. Yeah.
So in addition, another proposal, Junhua, the proposal author, author, and has explained why he wants this way, because there are some corner case like what if the uh, private class object is had been deleted or changed, and so in that case the scheduler still can schedule the result binding according to the previous private value.
Value, right? Yeah.
Yeah,
Yeah.
I agree with that because that's the same behavior as Kubernetes.
Yes,
Yeah.
exactly.
yeah. Mm.
So I think we can make a further discussion about how to so if we just need the priority value and preemption policy, then can discuss which place should be the place to propagate those values to the binding, right?
Yeah.
And
Yeah, does it make sense to still put it inside replica requirements, which will get passed to the resource estimators?
Um. Sorry, Leon. Do you mean I don't see any changes to the in resource interpreter, because the priority value and preemption policy will be will be set before or during the creation of a result binding. So we can do that by Karmada controller.
Yeah, I'm saying like the resource estimator will decide how many victims to preempt on each member cluster. So the scheduler needs to send a preemption request containing the preemptor's priority value and priority preemption policy. So if we do it that way, then I think it makes sense to put these information inside replica requirements, which is sent over on the gRPC request to the resource estimator.
But if you look down into the CLS settings, go to the bottom. There's insecure, sorry, not the bottom of the page, the bottom.
Yeah, so I think the problem is like the in the estimator gRPC request, it's reuse the resource requirement. So that is why we also need that fields in the
That would cause
in the
this field not.
yeah, we also need that in the resource requirement. Is that the so yeah, I think we discussed that before because in the estimator gRPC request, we reuse some resource.
Probably just create, right? Was that? I think
so.
No.
So the preemption logic, like the algorithm to find the victims, we designed to put that in the estimator. So for each available cluster, it will gives me the victim jobs for the low priority of the low priority job. So when so in the request, I need to know this job's priority class, and then the value. Okay.
Yeah, if you can go to the gRPC preemption request section. Yeah, we are trying to introduce two types of gRPC communication: preemption request and preemption response. So the request is asking the resource estimator, given this preemptor, how many replicas we want to fit into the cluster, the number of resource bindings, a list of resource bindings. That's like the best solution to preempt. And then, yeah, obviously the criteria of best is customizable according to the cluster admin. Yeah, I guess we're making an assumption here that preemption should only, a workload will not span multiple clusters. At least this is true for our ML workload compute job. So it choose a one member cluster and the resource estimator that lives on that cluster, and then ask it for the victim resource bindings to preempt. But in the case of you need to say preempt a deployment that has like or like a GAN job that spans multiple clusters, I think this response is also generic enough. Like you can provide a flag and just say, I want all of the resource bindings instead of the ones to preempt. So like it aggregates that information to the scheduler and then decides preemption across multiple clusters.
Quick question: do you have a real use case by now? trigger preemption at the same time among multiple clusters?
It's not our use case.
No, we don't.
You mean it's like for the future?
Yeah.
There's some possibility, right?
Yeah. In a case of that, I think this response is still generic enough.
Yeah. Yeah, sounds good to me. Yeah, and I think I just want to add that in this case we do need all the field of the priority class inside the replica requirement, right? Because you are it's the data because it's also included in the data structure you send, via gRPC to the estimator, and we definitely don't want estimator to do kind of extra query. I mean over the APIs, right? So yeah.
Yep, for sure.
Yeah. Yeah, that's clear.
So this is for the proposal. I just want to know what's the progress like? Is that possible like to reuse Volcano scheduler in Karmada? I remember you guys have a plan like the multi-cluster Volcano scheduler.
Yeah, the multi-cluster Volcano is currently under development. Actually, there's some initial pull request, and there's a new repository called Volcano Global.
Yeah,
but we have only the pending PRs, not yet a running version yet.
I see. So I just want to know the roadmap. The roadmap is more like the global Volcano scheduler will replace the Karmada scheduler. Like, is that the roadmap? But we still keep like Karmada other components like the controller for cluster management and also the API server things. Just want to know the roadmap for those two projects.
I think in a high level idea, the answer is yes, but there are still a lot of details not yet discussed. So yeah, that's the current status.
I see. So yeah, maybe then we need to
we
implement
will
our
see how much we can do with the first implementation in the Volcano Global. There's yeah, you can also take a look.
Yes.
Actually, I'm currently working with Volcano maintainers to try run schedule Volcano job on Karmada. So there is a proposal under discussing recently. So okay, I can send a proposal link after meeting. So Leon, do you? I think I remember you want to show a demo, right?
Yeah, we do have a demo prepared, but is this too late for you guys?
I see. Okay, so
essentially the demo was like we submitted 4 preempts of the same size, and then the cluster only has 4 GPUs, and each preempt uses 1 GPU. We send another preempter with higher priority, and it kicks off only one of the preempt because that's enough to fit in the preempter. And then And then we're using this like resource estimator workflow to decide how much victims to kick off. And then for the priority clause, we're kind of just passing it along in the annotation, so not in the ideal workflow.
That's saying when somebody tries to connect to a 443,
Okay.
actually use this.
In our current implementation, we query in scheduler. Yeah.
So the first thing is going to be the
Right.
Yeah, in our current query implementation.
Which one do you want to do the POC, or we can do that in the next community meeting?
Yeah, I can show a quick demo. Just depends on are you guys available? Because it's kind of late.
No problem. So let's do it.
Okay. I can.
Thanks.
Yeah, only
check.
like less than 5 minutes.
Oh yeah,
usually
actually,
best,
yeah. So basically, this is our in-house wrapper for our ML job, and there are 4
Sorry,
jobs.
are you
do you share your
sharing?
screen?
Oh, okay, yeah. I think it's this one. Okay, can you see my VS Code?
Yes.
So there are 4 compute job resource, and compute job is our in-house wrapper of our ML job, and they each consume 1 GPU. And in our cluster, we only have 4 GPU. So after those 4 are created, then there will be no resource for the other job. And there will be another preemptor job created after the preemptive job create, and we will show how preemptor job preempt the preemptive job. So first, sorry. Oh, sorry, my bad. Let me just create. I'm not in the correct context.
I thought the default was simple, but
okay. So first, there's no job, and we will create those 4 preemptive job. You can see then those 4 are all created. And they each consume 1 GPU. And after we create the preemptor job, there will be 1 being kicked off. And the preemptor has higher priority. And we can see that it's the first job got kicked off, and we can see we have a dashboard. Sorry, I thought.
Yeah, we turn on all the events.
Yeah, we turn on the events. And there will be preemptive events got emitted to show that this is preempted by the preemptor. This is our quick demo. And the reason for that there are 2 is because we have 2 clusters. So it's duplicate message.
Okay, got it.
And this is the simple version of our workflow.
So the implementation is not that complicated. The first one is like we have another queue implementation. The interface the same as the work queue, but the implementation is a priority queue. We can use a feature gate to protect that feature, like user can switch between the priority queue and the current work queue from the controller runtime. And then the other implementation is like the preemption logic is inside the estimator. we add two gRPC requests. We add one gRPC request to calculate the preemption. And then in the scheduler, we introduce the post scheduler logic. So the preemption happens after. It's very similar as the pod preemption plugin. Yeah. So, but it still have the limitation as we discussed. It will keep it doesn't fit into the elastic job. So it will kill the whole job instead of for the resource of the elastic job. Like it doesn't cover the elastic job use case. So for example, like we discussed for elastic job, they have the minimum replica, right? And we cannot like just kill the pod use resource more than the minimum replica. Instead, we will kill the whole job. The whole job and all the pods under that job. Yeah. And it also doesn't cover the case like for example, like deployment like pods scheduled in multiple clusters. It doesn't fit into that case.
No, that's what I do, right? So when you just switch to the OID. So the good thing is that app that writes to Kubernetes is owned by us.
Have you ever look at the Junhua's proposal?
Yeah. But they but in his proposal we didn't see the implementation
Yes.
So do you want to involve him? Like we discussed the algorithm for how to preempt the job, or like deployment if he has other requirements.
Yeah, sure thing. But before that, I think we next step we should try to make an agreement on the API part. So then after that we can dive into the implementation details.
Yeah.
So how about that? Can you maybe comment on Junhua's proposal about let me know which part you agree and which part you are not. So I need your opinions.
And do you think we can, because the community meeting is only like 1 hour, and for multiple people in the community, like, do you think we can schedule a time with Junhua only for this topic, or like only to go through the two proposals and then get the API?
Sure. I will talk to him. Actually, I invited him to that meeting, but it's too late in China, so I think we can do that. I will talk to him and organize another meeting. Okay.
Yeah. That would be great. Yeah.
Thank you so much.
Okay.
Yeah, thank you.
Thank you. Thank you, everyone.
Yeah. Thanks.
See you next time.
Thank you.
Thanks. Bye.
Thank you.
Yeah.
Bye.
See you.
Goodbye.
Bye.
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 Bye.